Okay, so I got another request for some help on the verifying trig identities worksheet. So I'm just going to kind of point you in the right direction for a couple of them and see if that helps you figure it out. If not, then maybe I'll just revisit this again. So looking at number 12, 1 minus cosine over 1 plus cosine is equal to cosecant minus cotangent squared. Right away, you should think conjugates. So whenever you have a conjugate in the denominator, you want to multiply that fraction, or when you have half a conjugate in the denominator, you want to multiply it by the other conjugate. And the bottom is going to become 1 minus cosine squared. And the top will be something that is more complicated. It's going to be 1 minus 2 cosine plus cosine squared. Okay. So let's see, what should we do now? Well, 1 minus cosine squared is on our Pythagorean identity. It is sine squared. Oh. So this is sine squared. So 1 minus 2 cosine plus cosine squared over sine squared. Okay. Now, you probably got stuck right here. What should we do? Well, on the other side, this is 1 over sine minus cosine over sine. But that's squared. So if I take this and multiply it by itself, then I should figure out a way to manipulate this to equal what that is. So in order for this to work, you kind of had to mess with both sides. I mean, you don't have to, but in this case it's a little bit easier if you do. So try multiplying out the right side and then see if you can manipulate it so it equals this. And it's a little bit tricky, but hopefully you can figure it out. If not, let me know and I'll give you more information. 14. Cotangent cosecant is equal to cotangent plus cosecant over sine plus tangent. A couple different ways to handle this. I'm going to try conjugates. So I'm going to do sine minus tangent, and who knows, it might not work. Sine minus tangent. So in the numerator, I get cotangent sine from there minus cotangent tangent. Cotangent minus times negative tangent is just going to be -1. And then this is cosecant sine. And then that is minus cosecant tangent over. The bottom is going to be sine squared minus tangent squared. All right. Is this what we want to do? So sine squared is 1 minus cosine squared. And tangent squared is secant squared minus 1. So that becomes 1 minus cosine squared minus secant squared plus 1. Looks like I've made it worse. So that would be 2. Okay, that didn't work. Let's try something else. So if I tried to combine this into a single fraction, sine squared over 1 minus sine squared over cosine squared. So to find a common denominator, I need to do cosine squared on this side, and then I get cosine squared sine squared minus sine squared over cosine squared. Now I can invert and multiply. We'll see what happens. It might be a bad idea. Cosine squared, and then on the bottom, wait a minute. Yeah. Alright, so cosine squared sine squared minus sine squared. Is that gonna, would that simplify down? Let me check something. If I pulled a sine squared out of this, I would get sine squared times cosine squared minus 1. But sine squared is 1 minus cosine squared. So that would be cosine squared minus 1 plus cosine to the 4th minus cosine squared. So those would cancel. I get cosine to the 4th minus 1. I think this is all bad. Starting over. I think that one would work, but we're not going to do it that way. All right, try again. Cotangent plus cosecant over sine plus tangent. Let's skip straight to common denominator here. So sine over 1 plus tangent, sine over cosine. I'm going to put a cosine over cosine on this side. And that's going to give me cosine sine plus sine over cosine. Now in the numerator, I have cotangent, which is cosine over sine, plus 1 over sine. Those already have a common denominator. So the numerator is cosine plus 1 over sine, and the denominator is cosine sine plus sine over cosine. Now I invert this and multiply, and hopefully from there you can figure out how to get that. Boy, that was much easier. So if you still struggle, let me know and I can help you out. Okay, let's take a look at 16. Secant over sine minus sine over cosine, and that's equal to cotangent. Well, two fractions here. Let's do common denominator. This one gets a cosine over cosine. This one gets a sine over sine. And I have cosecant cosine secant minus sine squared over cosine sine. That's equal to the cotangent do I want to go further, or do I want to let you figure that out? Oh. Yep. Yeah, that's actually pretty easy. Yep, that one's look at this. If you focus on that, you can do something that will make it work itself out pretty easily. All right, the last one, 26. 1 minus tangent to the fourth is equal to 2 secant squared minus secant to the fourth. Couple things here. If I had x squared minus 9, that factors into x minus 3 and x plus 3. Okay, if I flipped it around and I did 9 minus x squared, that's still going to give me x minus 3 and x plus 3, but we probably wouldn't factor it that way. We would do it this way: 3 minus x and 3 plus x. And it turns out that these are exactly the same. They look a little bit different, but the roots end up being plus or minus 3. So what if I had 1 minus x to the fourth? Well, that is 1 minus x squared and 1 plus x squared. And if you need to, this one factors again into 1 minus x and 1 plus x. You may not need that, but it does work. So on the left side, we have 1 minus tangent squared and 1 plus tangent squared. Well, one of those shows up on the Pythagorean identity list. So one of those can be changed to something that's a little bit easier. And if you do, then you can multiply that in, whichever way you need to, depending on which one simplifies. And then just a hint on the other side, if I pulled out a secant squared, then I would get 2 minus secant squared. Anyway, hopefully that's enough of a hint to allow you to solve that one. If not, again, let me know. I'll help you out. Good luck.